So this is review sheet C for our chapter 5 test. Use composites to prove or disprove if the functions are inverses. So you are looking to find if f of g of x equals x and g of f of x equals x. So f of g of x means I'm going to take the function f, the cube root of x minus 6 over 2, and I'm going to put g of x in here. And g of x is 8x cubed plus 6. So that's my g. And then I can simplify under the square root. It's 8x cubed plus 6 minus 6, which is 0. So now I have the cube root of 8x cubed over 2. The cube root of 8 is 2. The cube root of x cubed is x. So we have 2x divided by 2. And the 2's divide to equal 1x. So that one worked. Now the other way around, I'm going to take 8x cubed plus 6, and I'm going to put f of x in here. And that is the cube root of x minus 6 over 2. When I cube the numerator, the cube root of x minus 6 cubed is just x minus 6, and 2 cubed is 8. So I get 8 times x minus 6 over 8 plus 6. The 8's divide out, x minus 6 plus 6 equals x. So I got x both times, so yes, they are inverses. Same thing for number 2. So we're going to take f of g of x. So f is 5 minus x over 7. And we're going to put g of x in here. And then g of x is the 5 minus 7x. And so 5 minus 5 is 0. So negative 7x. This becomes plus. Negative times negative becomes positive 7x. And then 7. So negative, or 7x divided by 7 is x. And then the other way around, 5 minus 7 times x, and that's 5 over x over 7. Well, 7 cancels the 7 and leaves a 1, but that's a negative 1 times 5 minus x. So that's 5 minus 5 plus x, which is 0 plus x. So I got x both times. So yes, they are inverses. All right, using the rules of exponents to simplify, and we're not going to leave any negative exponents. So when we multiply powers, we add the exponent. So y to the 7/3 plus 5/3. 7 plus 5 is 12/3, which reduces to 4, y to the 4th power. Number 4, we're going to add 4/3 plus 3/3. So that's x to the 6/3 over x to the 1/3. Then we'll subtract our exponents. 6/3. 6/3 minus 1/3 is 5/3. So x to the 5/3 power. I'm going to put it down here. And number 5, let's simplify what's inside. 12 goes into 6 twice, or 6 goes into 12 twice. And then I'm going to move my a negative 2 up and my a to the 6th down. And I'm going to have b to the 5th, b to the 4th, and c squared. Because it's negative, it moves to the denominator. If it's negative in the denominator, it moves to the top. Okay, then it's to the negative 3 power. So I get 2b, because b to the 5th divided by b to the 4th is, subtract my exponents, b to the 1, which I don't need to write. And then 2 minus 6, the exponent on the a is a negative 4. That means a to the 4th is in the denominator with the c squared. And that's to the negative 3 power. The negative exponent flips the fraction. And then I'll raise everything to the 3rd power. A to the 12th, c to the 6th over 8. Don't forget to raise the numbers to that power. B cubed. And then number 6, you have 3 times 20 over 4 times 12. I can do some cross simplifying here. 4 goes into 20 5 times, and 3 goes into 12 4 times. So my fraction is going to be 5/4. I can switch these around. I can put x cubed on top and the x to the 5th on the bottom. Y squared. Then I have x to the 4th, y to the 9th. And then this x to the -2 can also go up, and the y cubed can go up. So let's see what we have. We have, let's look at our x's. 3 plus 4 plus 2, that's 7, 9. And then minus the 5 on the bottom. So that's x cubed times x to the 4th times x squared. That gives me x to the 9th on the bottom over x to the 5th, which is x to the 4th power. So that's 5x to the 4th. And then for the y's, I have another 4's on the bottom. Y squared, do a different color. Y squared times y to the 9th, that's 11. Plus 3 more is 14. Y to the 14th. So it's y squared times y to the 9th times y cubed. 2 plus 9 plus 3 gives me 14. That's my final answer. So graph using t-tables. So I'm going to move this a little bit. When we're graphing with the table, we're looking to find out where we should start. So 1/2 x plus 1 has to be greater than or equal to 0 because the square root cannot be less than 0. So we'll solve that for our starting point. 1/2 x is greater than or equal to -1. Times it by 2, x is greater than or equal to -2. So I'm going to make my table. Start with -2. And it's greater than. When I plug in -2, I get the negative square root of 0 plus 4. So it starts at 4. And this is a reflection, so it's going to be less than. So the domain is x is greater than or equal to -2. And the range is y is less than or equal to the 4 because the negative flips it. So because my square root has a 1/2 in there, I'm going to pick even numbers so that I don't have to deal with fractions. So I'm going to plug in 0. I have the negative square root of 1/2 times 0 plus 1 plus 4. That's the negative square root of 1 plus 4. That's -1 plus 4, which is 3. Oops, put that in the wrong spot. So that's 3. And then I'm going to plug in 2. I get negative square root of 1/2 times 2 plus 1 plus 4. That's negative square root of 1 plus 1 plus 4. That's the negative square root of 2 plus 4, which is some decimal. I'm going to plug in 4. I get negative square root of 1/2 times 4 plus 1 plus the 4, which is 2 plus 1, negative square root of 3. So I told my students to just keep going until they find a perfect square. 6 negative square root of 1/2 times -6 plus 1. Oops, not -6, +6. Negative square root of 3 plus 1 plus 4. That's the negative square root of 4 plus 4, which is -2 plus 4. Okay, and that equals 2. So I have 3 good points here, -2, 4. That's where it starts. 2, 1, 2, 3, 4. And then I have 0, 3. And then I have 6, 2. 6, 2. And there's my graph. And if you're asked to describe that, that is a a horizontal translation. Just as a side note, left 1, a horizontal stretch with a factor of 2, which is why it moved from 1 to 2. That's a reflection in x, and then it's a vertical translation up 4. Okay, let's look at number 8. 8 is actually a cube root, which doesn't have any domain issues. So let's look at this function. What is going to make the underside 0 is 1. So the cube root of 1 minus 1 plus 3. That's what makes it 0 underneath. So 0, 3 is where we're going to start. At 1, 3. 1, 3. So this is 1, 3. That's what I plugged in. And then we need underneath here to make it numbers I can use to equal 8, the cube root of 8. So that's 9 minus 1 plus 3. That's a cube root of 8 plus 3, so 2 plus 3, 5. So 9, 5. And then I believe we can make what's underneath equal 1, cube root of 2 minus 1. So cube root of 1 plus 3, 1 plus 3 is 4. So 2, 4. And then when I plug in 0, let's make some space here. I get when I plug in 0. So far I have this table. It's kind of weird. 1, 3, 2, 4, 9, and 5. And then 0. Let's see what we get. Plug in 3. 0 minus 1 is negative 1. Plus 3, negative 1 plus 3 is 2. And then let's go to 10. Nope. No, 7. Negative 7. Cube root of negative 7 minus 1. That's a cube root of negative 8. That's negative 2 plus 3 is 1. So this is a graph we haven't really looked at. I don't believe we're putting any of these on the test, but, oops, it's at 1. And that's 1. So it looks like this. That's your cube root function. The domain and range are all real numbers. I think the test is only going to have square root functions on it, though. Okay, next I have the cube roots. I have all cube roots, so what I'm going to do is I'm going to write this as one big cube root. Y to the 6th over 27y times y to the 11th. And that's the cube root of y to the 6th over 27y to the 12th. That's y to the 1. So add my exponents times y to the 11th. And then let's see, we'll simplify. 6 minus 12 is negative 6. So the cube root of 1 over 27y to the 6th, which is 1 over 3y squared. Cube root of 27 is 3. Cube root of y squared is, or y to the 6th is y squared. Number 10, let's simplify each of the square roots and then we'll add up what we can. This is 16 times 2, so that's 4 square root 2. This is 9 times 2, so 9 times 3 square root 2. And this is 25 times 2, which is 2 times 5 square root 2. So that's 4 square root 2 plus 27 square root 2 minus 10 square root 2. 31 square root 2 minus 10 square root 2 is 21 square root 2. Number 11, we're going to multiply 5 minus 2 square root 3 times 5 minus 2 square root 3. So 2 square root 3 times 2 square root 3, we multiply negative 2 and negative 2 is positive 4. And the square root times the square root of 3 times the square root of 3 is the square root of 9, which is 3. So I end up with 12 here, positive. Then negative square root 3, negative 2 square root 3 times 5 is negative 10 square root 3. And then 5 times negative 2 square root 3 is negative 10 square root 3. And then we have 5 times 5 is 25. And 25 plus, that's 12, is 37 minus 20 square root 3. All and number 12. We're going to multiply what's out front, which is just a -2. And I'm going to write this fourth root as 8 times 11 times 4 times 11. Okay, I don't like multiplying 8 times 44 together and then breaking that back down. I feel like that's more work than I need to do because I end up back where I started from. So I have 8 times 11, 4 times 11. 8 is 2 times 2 times 2, and 4 is 2 times 2, and then we have 11 times 11. And it's a fourth root, so we're looking for groups of 4. 1, 2, 3, 4. So that's a -2, and that +2, this group of 4 comes out. And I have the fourth root of 11 times 11 is 121. 121 times 2 is 242. So I have -4 times the fourth root of 242. Okay, number 13, we're solving square root functions. So I need to square both sides to get rid of the square root first. And that's x squared minus 8x plus 16, because don't forget when we do x minus 4 squared, that means x minus 4 times x minus 4. And that has to be multiplied out, and that equals 2x. And subtract my 2x. X squared minus 10x plus 16 equals 0. And I can factor that. What two numbers multiply to positive 16 and add to -10? That's -8 and -2. So x equals 8 and 2. And now we got to see which one works. Plug in the 8. 8 minus 4 equals the square root of 2 times 8. That's 4 equals the square root of 16. 4 equals 4. So 8 works. And then 2 minus 4 equals the square root of 2 times 2. That's -2 equals the square root of 4. -2 doesn't equal +2. So our extraneous solution is the 2, and our solution is 8. Number 14. I want to get my parentheses with the exponent by itself. This is an exponent of 1/3. So I'm going to subtract 3. And I get 6n minus 5 to the 1/3 power equals -5. To opposite of 1/3 power is raising it to the third power, right? Because that's a cube root, really. If you wanted to, you could write that as a cube root of 6n minus 5, and I'd still be raising it to the third power. So I get 6n minus 5 equals -125. Add 5, so 6n equals -120. Divide by 6, and n equals -20. And I can plug that in to see if it works. 6 times -20 minus 5 to the 1/3 power. That's -120 minus 5, which is -125 to the 1/3. -5 plus 3 equals -2, and it checks. And number 15, this is the fun one. I got to square both sides to get rid of that square. So I get x plus 15 on this side. But on this side, it's 5 plus the square root of x times 5 plus the square root of x. And then x square root of x times square root of x is x. And I get 5 square root x. That's the square root of x times 5. And then I'm going to do 5 times the square root of x again. So I get another 5 square root x. And then 5 times 5 is 25. So I get 25 plus 10 square root x plus x equals x plus 15. Now I got to get this x squared, square root of x by itself. So I'm going to subtract x. So I get 15 equals 25 plus 10 square root x minus 25. And we get -10 equals 10 square root x. Divide by 10, and -1 equals the square root of x. I square both sides. I get 1 equals x. But right here we should think red flag, something's wrong. Because the square root can't equal a negative. So this probably is not going to work when I plug it back in. I get the square root of 1 plus 15 equals 5 plus the square root of 1, which is the square root of 16 equals 5 plus 1. 4 does not equal 5 plus 1, so this one has no solution. Here's some more solving. So we're going to add 10 to both sides. 2x minus 3 to the fourth equals 162. Divided by 2. X minus 3 equals 81. X minus 3 to the fourth. And now I'm going to take the fourth root. X minus 3 equals plus or minus 3. The fourth root of 81 is 3. And then we're going to add 3. So x equals 3 plus or minus 3. X equals 3 plus 3 is 6, and 3 minus 3 is 0. So 6 and 0. And then number 17. Subtract 18 from both sides. My goal is to get the n plus 1 to the cube by itself. So 2/3 times n plus 1 cubed equals negative 18. We're going to multiply by the reciprocal to get rid of that fraction in front. Remember, that's 18 over 1. So n plus 1 cubed. 2 goes into 18 9 times. And negative 9 times 3 is negative 27. Then I can take the third root to undo the cube. And there's no plus or minus with odd roots. Plus or minus is only on even roots. So plus or minus on even roots. Square root, fourth root, sixth root when solving. So that's n plus 1 equals negative 3, the cube root of negative 20, and minus 1, and equals negative 4. Is negative 3. Oops. Okay, given f of n equals 2n squared minus 3n plus 2, and g of n equals negative 4n squared plus 2n, find f plus g, f minus g, and f times g. So let's start with the easy one, f plus g of x, which just means I'm adding 2n squared minus 3n plus 2 to negative 4n squared plus 2n. And we get, let's see, negative 2, let's use a little color here, negative 2n squared minus 3n minus 2n, let's put that in a different color here, negative 3n plus 2n gives me minus n, and then plus the 2. Then f minus g, 2n squared minus 3n plus 2 minus negative 4n squared plus 2n, which becomes plus 4n squared minus 2n. And then I can find my like terms. 2n squared plus 4n squared is 6n squared. And then negative 3n minus 2n is minus 5n, and then plus 2. Some people left that off when you're combining things, so don't forget the constants. And then lastly, f times g, which could also be written as fg. So that's 2n squared minus 3n plus 2 times negative 4n squared plus 2n. You know how I like my vertical multiplication. So I have 2n times 2 gives me 4n. Then I have 2n times negative 3n gives me negative 6n squared. 2n times negative 2n squared is 4n squared. Then we have negative 4n squared times 2. I'm lining up my like terms, so negative 8n squared. Oh wait, I made a mistake here. Let's go back. This is not squared. N squared times n squared is n to the fourth. Okay, that's better. And then let's see, where are we? 4n squared times negative 3n. That's negative 12n cubed. And these don't line up. So I'm going to move this over. 4n to the fourth. And then negative 4n squared and 2n squared is negative 8n to the fourth. Because we're multiplying, then we'll add up our like terms. Negative 4n to the fourth minus 12n cubed minus 14n squared plus 4n. And that is your f times g. And now we have f of n is n squared minus 3n, and g of n is negative 3n plus 2. We're going to find f of g of negative 1. This means take negative 1, plug it in for g, and then take that answer and plug it in here. So we're first going to find g of negative 1. Negative 3 times negative 1 plus 2. That's 3 plus 2, which is 5. Now we're going to plug that into f. F of 5 is 5 squared minus 3 times 5, 25 minus 15, which is 10. So f of g of negative 1 equals 10. Okay, so that's what it means when it gives you a number here. You're going to plug that number into this function, and then you take that answer and you plug it into the other function. So here, g of f of n means I'm going to take g, and I'm going to plug the function f into, so that's n squared minus 3n, right? So g is going to have n squared minus 3n put in for it. So that's negative 3 and n squared minus 3n plus 2. So the red is g and the blue is f. So f, g of f of x. So g has f plugged in. So that's negative 3n squared plus 9n plus 2. And you're going to get something different when you do f of g. G is negative 3n plus 2. So that's n squared minus 3 times n. And in each of those n's goes the 3n plus 2. Okay, we got that. Don't forget the negative sign in there. So that's a negative that I forgot. So now you have negative 3n plus 2 times negative 3n plus 2. That's 4. 2 times negative 3n is negative 6n. Negative 3n times 2 is 6n. And negative 3n times negative 3n is 9n squared. So we have 9n squared minus 6n plus 4 equals positive 9, or sorry, plus 9n minus 2. We combine our like terms, 9n squared. No, this is 12n. Made a mistake. 12n. And negative 12n plus 9n is minus 3n plus 2. And that's my final answer. Find the inverse of the function. 3 steps are change f of x to y. So y equals 2/3 x minus 10. Swap your x and y. So x equals 2/3 y minus 10. And then get y by itself. So we're going to add 10. X plus 10 equals 2/3 y. And multiply by the reciprocal, 3/2. And we get 3/2 x plus 30 halves is 15. 15 equals y. And that's our inverse. Now b gives us a list of points, 5, 2, 3, negative 6, 0, 4. This should be the easiest one. The inverse of this, g inverse of x, that's some little notation for you, is swapping your x's and your y's, 2, 5, negative 6, 3, and 4, 0. Now the inverse of the volume, we're not going to switch the variables because the variables have a lot of meaning here. Radius and volume. Remember, pi is not a variable, so we're not going to solve for that. So basically, we're going to solve the equation. This means solve for r. We can't get, if we swap the variables, it won't make any sense. So we're going to multiply by the reciprocal of the fraction, 4/3. So we get 4/3 v equals pi r squared. We're going to divide by pi. divided by pi. So when we do 4/3 divided by pi, that's 4/3 times the reciprocal, 1 over pi, which makes it 4 over 3 pi. So we get 4 over 3 pi v equals r squared, and now we take the square root. So we get the square root of 4v over 3 pi equals r. And we don't do minus, plus and minus, because radius has to be positive. Okay, last 5. Simplify using absolute value when appropriate. So we have 8 and 40. We can divide those exponents, -2 to the 5th power. When we have an even root of an even power, and it ends up equaling an odd power, we need the absolute value around it. So that's the absolute value of -32, which is 32. Number 22, the cube root of -8 is -2. The cube root of a cubed is a. And 3 doesn't go into 14 evenly, so we get the cube root of b to the 14th. Well, 3 goes into 4 times. So there's 4 b cubes in there, so that's b to the 4th. And then cube root, well, what's left over is 2. There's 2 more. So b squared is left underneath. And a more concrete way of looking at that is 3 goes into 14 4 times with the remainder 2. And so the whole number goes on the exponent outside, and the whole number goes on the exponent outside, and the remainder goes on the exponent inside. So here we have the 4th root of 81, which is 3. Again, here we're doing 4 goes into 38 9 times. So x to the 9th is it goes outside. That's 36. So it's remainder 2. So inside the 4th root, I'm going to have an x squared. And then 4 goes into 17 4 times with remainder 1. That makes it y to the 4th. And then 1 more y stays inside. Remainder 2 on that one. Here we have the 6th root of -216, a to the 6th, b to the 24th. Now these are both even powers, so even if I put in negatives, they're not going to make this negative a positive, so this one is no real solution. Okay, and lastly, we're going to take the square root of x to the 4th, y to the 13th. The square root of x to the 4th is x squared. And then again, we're going 2 goes into 13. How many times? 6 times, y to the 6th, with 1 left over. So we still have square root y left under the radical.